Hello, I'm going to do a series of videos covering some of the trickier 6 mark level response questions in the Year 12 depth papers. So it's probably worth you maybe pausing and having a look at the question before listening to the solution. But I'm going to go through the answers now. So question here is about electrophilic addition reactions. So you've got compound A there with a carbon-carbon double bond, so it's an alkene, reacting with hydrogen bromide. It tells you it's going to form 2 products. So, parts of the question, 3 clear points here. So we've got giving the 2 possible structures, outlining the mechanism for one of those compounds that you pick as your products, and then explaining which of the 2 products is going to be more likely to be formed, so what we call sometimes the major product. So let's go through this reaction. So first thing, we want the 2 products. So addition reactions, we break the double bond. Everything that was on there already remains. So I'm going to put these methyl and hydrogen groups on here. And then we add the hydrogen onto one and the bromine onto the other. The only difference with the other product is that hydrogen and bromine will switch onto the opposite carbons. So again, same stuff there. This time though, bromine there, hydrogen there. So there are 2 products. Next, we need to do the mechanism for one of those, not both. It's the same mechanism, so you'd be just repeating the same stuff over again, so you're kind of wasting your time. So I'm going to pick, because it's the first one I drew, I'm going to pick the mechanism for this one on the left. So let's have a look at the curly arrow mechanism for this reaction. So I'm going to start with our alkene. And before you do any curly arrows, think about lone pairs and dipoles. So most mechanisms, they're going to be the key things to getting these started. So key thing on this one is on the electrophile, the hydrogen bromide has a delta positive charge on the hydrogen, a delta negative charge on the bromine because it's more electronegative. So the electrons in the double bond are going to be attracted to the hydrogen. So we start a curly arrow on the double bond and take it to the hydrogen. Do make sure it curls. I know it might seem pointless, but they are called curly arrows, so they do need to curl. That hydrogen is about to form a new bond with the carbon on the left, so it can't form a bond with the bromine at the same time. So the bromine is going to take those electrons. So we have an arrow coming from the bond between the hydrogen and bromine going to the bromine atom, which is going to break that bond. So let's have a look at the intermediate. The intermediate is really important in these mechanisms. So we've now got a single bond. We've still got all the original stuff on there. So the 3 methyl groups and the hydrogen. Now this time we've added that new hydrogen on here, onto the first, or the carbon on the left. The carbon on the right, however, doesn't have anything extra on it at the moment, so it's going to have a positive charge. Now this, remember, is called a carbocation and is important for picking the more stable, or the major product, sorry. The more stable carbocation will form the major product. So we've also got the bromide ion that we formed, and this has a lone pair. I mean, it's got more than one lone pair, but one lone pair that we're interested in on it there. So that negative bromide ion is going to be really attracted to that positive carbocation. So final thing is curly arrow there, showing a formation of a bond between the carbon and the bromine. And that will then lead us to the product that we had on the left. Sorry, my words aren't working very well today. So we've then got our product. The only difference, if you were to do the mechanism for the product on the right, would be that initial hydrogen would be going on to the right-hand carbon in the double bond instead of the left-hand carbon. Other than that, pretty much identical. Okay, so we have given the two structures, we've outlined a mechanism. Now we just need to explain which of the two organic products is most likely to be formed. And this is down to the carbocation intermediates. So I'm going to label these as 1 and 2. So we have to look at the intermediate species we have for compound 1. So if we look at the carbocation 1 is the one we've already drawn. So it's positive charge on that carbon, hydrogen, and carbocation 2, the one that we haven't drawn, looks like that. Let's just bring this a bit. Yeah. So we have to look at these two carbocations. Now, if you remember from your lessons, the more stable carbocation will be the one that has more carbons directly bonded to the positive carbon. So if we just have a look and count them, carbocation 1 has 1, 2, 3 carbon groups directly bonded to that carbon, whereas in carbocation 2 we've got 1, 2. So because carbocation 1 has more alkyl groups bonded to the positive carbon, it is more stable. So because it's more stable, it means that compound 1 is the more likely product. Hopefully that makes sense. Feel free to email me if you want any clarification on there. Okay, back again. Quick look at the mark scheme here. We can see what's expected. See, the key scientific points here are structures for the two products. You don't need names there, as you can see. It could be structural, displayed, or skeletal formula. As long as the structure is clear, it doesn't matter which one you pick. See the mechanism underneath, 3 curly arrows, dipoles, lone pairs, and charges are the key things. And you can have one or the other. And just over here, major product. It's identifying the major product. And you can see the key statement there is because it has the most stable carbocation intermediate. A couple of alternative ways of wording that, but that's what it boils down to. Now, marking on these quite tricky to determine until you're used to these, but generally speaking, if you get in all 3 scientific points, you're going to be in the top level, level 3. If you're making some mistakes on those, or you've only got 2 really well explained, you're probably in level 2. And then if you've made multiple mistakes or only explained 1 thoroughly, then you're in level 1. Okay. I'll leave that video there. Hopefully it's been useful.